Hello students, today let us learn one topic, probability, from class 10th. Now in this video we are going to learn some basic concepts regarding the probability. So in simple words, probability means the possibility. We can find the possibility of various events that occur in day-to-day life. So in mathematics it is called as the probability. Suppose one event is given and we have to find the probability of that event to happen. We can calculate it mathematically. How to do that we are going to learn in this topic. But before that we must learn some basic terms which are necessary for this topic. So start with the random experiment. Before we know what is a random experiment, let us have some examples. Suppose the first example is tossing a coin. So if we toss a coin, there are two possibilities that we get. Either we get head or tail. Let's have the another example of throwing a die. We know that die has 6 surfaces and each surface has one number on it. So there is a possibility of having number on the upper face. So as there are 6 surfaces, we can get any number from 1 to 6. Let us have another example, picking a card from a set of cards bearing numbers from 1 to 50. So if there are 1 to 50 cards and from that we have to choose any one, we can get any one number from 1 to 50. And let us have another example, picking a card from a pack of well shuffled playing cards. We know that a set of playing cards has 52 cards. We have to select any one of them so we can get any one playing card out of those 52 cards. So if we consider all these examples, these are the experiments for which we know the possible results. Because if we have tossing a coin, we know that there are only two possibilities, either head or tail. Suppose if we have an example of throwing a die, then we know we get any number from 1 to 6 on the upper face. So in these examples, we know all the possible results, but we cannot tell exactly which result would be there. So such experiments are called as random experiments. So let us have the definition of it now. The experiment in which all possible results are known in advance, but none of them can be predicted with certainty, and there is equal possibility for each result is known as random experiment. So these are the examples of some random experiments. Let us have the next concept, outcome. Its definition is result of a random experiment is known as outcome. So whatever random experiment is there, results of its are known as outcomes. Let us have one example. Tossing a coin. So there are two possibilities that we can get. That is, there are two outcomes. Either we get head or tail. So these are the results we can get by these random experiments. That's why these are the two outcomes of a random experiment tossing a coin. If we have another example, in a random experiment of throwing a die, there are 6 outcomes. So on the upper face, we can get 1 or 2 or 3 or 4 or 5 or 6. So any number amongst all these we can get. That's why these are called as outcomes of random experiment throwing a die. Suppose if we have another example in a random experiment of picking a card bearing numbers from 1 to 50, there are 50 outcomes because we have to select one card from 1 to 50. So any card we can get which has a number from 1 to 50. That's why there are 50 outcomes. Now the next concept is the sample space. The set of all possible outcomes of a random experiment is called as a sample space. That means suppose if we toss a coin, we get either head or tail. If we collect these 2 points, we get a sample space of a random experiment. Sample space is denoted by letter S or omega, and the number of elements in the set S is denoted by n of S. Now let us find out the sample space for some random experiments. First of all, let us consider the first random experiment, that is, one coin is tossed. If one coin is tossed, either on the coin we can get head or we can get tail. So these are the two outcomes that we get in a random experiment. One coin is tossed. So for this one, the sample space would be S is equal to, in curly bracket, H and T. H for heads and T for tails. That means sample space is denoted by a letter S. We have to write the sample points in a curling bracket. So here we have written S is equal to curling bracket HT. These are the outcomes for this random experiment. So the sample space is S is equal to HT. And as you can see here, there are two possible results. That means there are two outcomes for this random experiment. Therefore, the number of sample points in set S is n of S is equal to 2. Let's have the next random experiment. Two coins are tossed. Now we have to toss two coins simultaneously. So on first coin we can get both coins which are heads. This is the first possibility that we may get. The second possibility is on the first coin we can get head and on the second coin we can get a tail. This is the second possibility, that means second outcome. The third possibility is on the first coin we can get tail and on the second coin we can get H. And the fourth possibility is on both the coins we can get a tail. So these are the only four possible results that we may get in this random experiment, that is two coins are tossed. So the sample space would be S is equal to HH is the first possibility, head head, so it is written as HH. Second possibility is HT, that means head and tail. The third possibility we can get tail and head, that is TH, and or the fourth possibility tail and tail, that is TT. So for this random experiment, possible outcomes are 4 here. That's why the number of sample points in set S would be n of S is equal to 4. Now let us have the next random experiment where three coins are tossed simultaneously. So if we toss three coins at the same time, we get a sample space as S is equal to HHH. So this is the first sample point where on all the three coins we can get head. The second possibility we can get HHT, that means on the first coin we can get head, the second also we can get head, and on the third one we can get tail. This third possibility we can have head on the first coin, tail on the second coin, and again head on the third coin. So in this way we can get fourth possibility as THH, fifth possibility as HTT, sixth possibility as THT, seventh as TTH, and in the last possibility we can have all the tails. So in all 8 sample points we can get for this random experiment. That's why the number of sample points in S would be 8. Therefore n of S is equal to 8. Now the next random experiment is a die is thrown. As we know that die has 6 surfaces which has numbers from 1 to 6 on each surface. So if it is thrown on the upper face, we can get any number from 1 to 6. Either we can get 1 or 2 or 3 or 4 or 5 or 6. So if die is thrown, we can get any number from 1 to 6 on the upper surface. So the sample space for this random experiment would be S is equal to 1, 2, 3, 4, 5 and 6. These are the 6 sample points for this random experiment. Therefore, number of sample points in set S is equal to n of S is equal to 6. Next random experiment is 2 dice are thrown. Suppose if we have 2 dice and we have to throw those 2 dice at the same time. The sample space would be 1, 1, 1, 2, 1, 3 up to 1, 6. That means for the first possibility on both the die we can get number 1. For the second possibility on the first die we can get 1 and on the second one we can get 2. In this way for the sixth possibility, the first die we would have 1 and on the second die we would have 6. Now if we start with 2, that is we can get 2 on the first die and we can get 1 on the second. In this way we can get 2 on the first die and 6 on the second. So in this way we have all the possible results like 3-1, 3-2, 3-3 up to 3-6, or we can have 4-1, 4-2 up to 4-6, or 5-1, 5-2 up to 5-6, and 6-1, 6-2 up to 6-6. So these are the 36 results we can get if we throw 2 dice at a time. That's why the number of sample points in set S are 36. Therefore, n of s is equal to 36. Now we have another random experiment. If we have to select a card from a well-shuffled pack of 52 playing cards, and for this we must know what are 52 playing cards. So there are four types of cards in the playing cards, that is the diamond, spade, heart and club. Out of which, as we know that diamond and heart are red colored, whereas spade and club are black colored. These are the two colored pairs in 52 playing cards. We must know one thing here, that the jack, queen and the king of each type, these are the cards which has faces, and all other cards has the numerical values. Now we have to draw one card from a well shuffled 52 playing cards. We can get any one card out of all these 52 cards. So the number of sample points for this random experiment would be 52. That's why n of s is equal to 52. So there are 52 sample points for this random experiment. So these are the some random experiments for which we have studied the sample space and number of sample points in that sample space.